Imagine leaving your computer tower locked in, like a secure vault, driving 6 miles to the next town over, plugging in a monitor, and editing uncompressed 4K video with literally zero lag.
I mean, it sounds like sci-fi, honestly.
Right. But welcome to the deep dive. Our mission today is to decode the spec sheet for this piece of AV gear, the Smart-AVI DFX-XT-2P-RX-S, which takes that crazy logistical puzzle and makes it a reality for you.
Yeah, it's a highly specialized piece of kit.
It really is. Okay, let's unpack this. Why on earth would anyone possibly need to send a dual 4K video signal over 6 miles away from the actual computer?
Well, in certain high-stakes environments, having your hardware physically next to your monitor is just a massive security liability, or an operational one. You need distance. And what's fascinating here is the sheer scale of how this device bridges that gap.
Yeah, the specs are wild.
Right, we're talking about transmitting dual-head DisplayPort video.
Yeah.
That's 3840 by 2160 resolution, along with transparent USB 2.0 and stereo audio up to 10 kilometers.
Wow.
Yeah, 6.2 miles via single-mode fiber or 500 meters on multi-mode fiber.
Wait, let's break down those fiber terms for a second. Single mode versus multi-mode. I imagine transmitting uncompressed 4K video that far requires, I don't know, ridiculously expensive specialized wiring.
You'd think so, right? But the mechanism is actually elegantly simple. It relies on conventional, inexpensive dual fiber cables, not those luxury shielded copper wires.
Oh, really? Just standard fiber.
Exactly. Fiber optics transmit data as pulses of light, right? Single-mode fiber uses a ridiculously narrow core to shoot a single ray of light straight down the pipe.
Right, so it's a straight shot.
Yeah, because the light isn't bouncing off the walls, the data doesn't degrade, which is how you hit that 6.2-mile mark.
Ah, got it.
Now, multi-mode has a wider core, so multiple light rays bounce around as they travel. And that scattering causes signal degradation over long distances, which is why multi-mode taps out at 500 meters.
That makes perfect sense. The narrower the pipe, the straighter the light beam, the further the data goes.
Precisely.
And you're doing this with less than 4 milliseconds of latency? You wouldn't even perceive a lag at all. But wait, shooting a perfect 4K signal 6 miles down some underground fiber optic cable introduces, like, dozens of potential failure points.
Oh, absolutely.
Yeah.
Construction, traffic, you name it.
Right. So if a heavy truck rumbles past a conduit and vibrates the cable, what stops the host computer from instantly disconnecting your keyboard and crashing your whole workflow?
Well, if we connect this to the bigger picture, the manufacturer solves that exact vulnerability with a technology called uninterrupted emulation.
I'm stuck on the emulation part because if I unplug my mouse from my regular computer right now, the system dings, it freaks out, and tries to reset the device.
Yeah, you get the little error sound.
Exactly. So what does this all mean for the user? Are you saying this box is acting as a digital stand-in so the server never actually knows I stepped away?
Basically, yeah. Think of uninterrupted emulation, like putting a heavy brick on a car's gas pedal. The engine just keeps revving, completely unaware that the driver has actually left the vehicle. The receiver constantly feeds the host computer the specific electronic signatures of your keyboard, your mouse, and monitors.
Oh, wow. So even if the physical connection to the remote user drops for a fraction of a second because of that cable vibration,
The computer still sees the brick on the pedal.
it never registers the drop. The computer just hums along.
Yeah, it actively prevents the operating system from deactivating the peripherals or forcing a hard reset. In mission-critical applications, like intense data processing or, say, running an interactive emergency conference.
Yeah, you can't afford a crash there.
Right, that bulletproof stability is non-negotiable.
Well, here's where it gets really interesting. It's not just a one-way street to that distant desk. The transmitter unit features 2 local monitor connections right at the source.
Back in the secure vault.
Exactly, meaning a tech standing by the server rack can watch my exact mouse movements locally while I'm 6 miles away.
Yeah, it creates total workflow oversight. You have a technician monitoring the hardware and the data streams in real time alongside you, the remote user.
Which is a massive security feature.
Oh, for sure. If an issue arises at your end, the local technician can see exactly what's happening on the screen without needing to be in the same zip code as the person actually typing.
It's wild to see how much utility is packed into this thing. I mean, this single device, which currently prices out around $679, completely redefines the limits of remote hardware setups.
It really does.
We're not just moving a monitor across a room anymore. We're moving a workstation across a city without losing a single pixel of detail or dropping a keystroke.
Yeah, and this raises an important question for you to ponder.
What's that?
If you can place your vulnerable hardware miles away in a secure, climate-controlled server room without sacrificing that crystal-clear 4K quality or a single millisecond of reaction time,
Mhm.
how might this permanently reshape the architecture of secure office buildings in the future?
Mm-hmm.
I mean, if your tower can comfortably sit in another town, why would you ever need a bulky heat-generating computer at your desk again?